Hello everybody, we're going to recap the notes that you had from yesterday on ionic and covalent bonds. Now for ionic bonds, remember that you must have a metal and a nonmetal, and one of your valence electrons is going to transfer to the other element. Okay, so if I have a salt particle, remember these go with your valence electrons. Sodium has one valence electron. Chlorine has 1, 2, 3, 4, 5, 6, 7 valence electrons. Now for the loose dot structures that are coming up, for that purpose, I'm going to leave the empty space on the side that's closest to the other element. And this here will be your transfer of your sodium valence electron to chlorine. Now, because of that octet rule that you talked about yesterday, chlorine is going to have all 8, and sodium is sharing or actually transferred that electron to the chlorine. Now, a crystal, or most of your salts are going to, this is a crystal lattice. Lattice model. And so for every chlorine, you have another sodium, you have another chlorine, another sodium, and you see how it doesn't matter how you spin this actual structure, it will always have the same pattern. That's called a crystal lattice. Now here you have a covalent bond, and how do we know that it's covalent? Because you have two nonmetals coming together. So here carbon has a valence electron number of 4, and hydrogen has 1 valence electron. Because of this, covalent bonds share electrons. Okay, so this bond right here is going to share from dot to dot. You have 1 valence electron on each side of that bond. So when you have one bond, you have 2 electrons sharing. When you have a double bond, you have 4 electrons sharing. When you have a triple bond, 2, 4, 6, you have 6 valence electrons sharing in that bond. That third bond, when you have, the more the bonds you have, the stronger the bond is. And here, let's finish off that. And that's what's showing up here. Whoops, this should be an H. And that's what's showing over here. So these two that are sharing, it's your 1 valence electron from hydrogen and your 1 from carbon. Okay, so a little recap. A metal and a nonmetal gives you an ionic bond. Okay, to be a covalent bond, you must have a nonmetal and a nonmetal, or a metalloid and a nonmetal. But most of the time, what we're working in this class is a nonmetal and a nonmetal. Okay, now, can I have both? Yes, you can. So if I have something like NH4 and ammonium and bromine, NH4 is actually a plus charged polyatomic ion. Bromine is a negative charged nonmetal. Therefore, that's an ionic bond. However, whenever you have 3 or more elements, it can be both, because that will be an ionic bond, but then you have nitrogen and hydrogen and bromine, so you have 2 nonmetals. That's going to be a covalent bond as well. Okay, so anytime you have 3 elements or more, it's a both, ionic and covalent. So if I have something like, let's say, barium and a phosphate, should be 4. This would be both. Okay? Okay, so just a little recap. Ionic bonds transfer or steal an electron, you always have an electron cloud on metallic bonds, and covalent bonds share. If you have more than one element, like this, it will be both ionic and covalent. So what you're going to do today is you're going to identify, is it an ionic bond, or is it a covalent bond, or is it both? Okay, and here are just a few notes. If you want, you can pause or take a screenshot just for your notes. And also, you can say that your bonding goes with your charge, but really what it goes with is your valence electron. But if you take your periodic table, go ahead and label that first group has a +1 charge. You're going to be using these from now on. Your second group has a +2 charge. Your boron family has a +3 charge. Now carbon is a ±4. I always have students, ma'am, how come it can be plus or minus? Well, remember that you can only have 8 valence electrons around your element. And so carbon has 1, 2, 3, 4. A plus charge means you're going to lose all 4. A negative charge means you're going to gain all 4. So if I'm using hydrogen, hydrogen's actually going to share with carbon, and carbon's going to have all 8. However, if I'm using fluorines, fluorine has 7 valence electrons, and so it's going to take the valence electron from carbon. Okay, and now fluorine will have all 8. Okay, now the nitrogen family has a -3 charge, your oxygen family has a -2 charge, and your halogens have a -1 charge. Now remember, this last group are your noble gases. And your noble gases already have all 8 valence electrons, so they're not going to want to share or transfer with anyone. Okay, we're going to go over a few more on oxidation numbers later. But for today, I want you to identify whether it's an ionic or covalent bond or both, and you're going to do that types of bonds practice assignment. It is for a grade, and it's in your folder. Bye.